Linear velocity describes the manner in which an object travels at a specific instant. In uniform circular motion, even though the speed remains constant, the direction of the linear velocity changes continuously, at every instant, pointing along the tangent to the circle. This implies that as long as the object is in motion, its linear velocity is never zero. Since its direction is aligned with the tangent at any given moment, it can never be zero. The rate at which an object travels around a circle is what we call linear speed. This is sometimes also referred to as tangential speed. The formula used to calculate it is quite simple. V equals 2 pi r divided by t. This gives average linear speed. Here r represents the radius of the circle. That's right, the total circumference of the circle is 2 pi r. If we divide this total circumference by the time taken to complete one full revolution, that is the time period, we obtain the linear speed. Let's clarify one point here. As we listen to all this, it might seem as though linear speed relates simply to the physical distance we cover while running along the track. However, we aren't moving in a straight line. We are moving in a circle. This means that when viewed from the center, the angle at which we are positioned is constantly changing. So how do we measure that? That is an excellent point. While the steps you take on the track, or the distance you cover, indicate your linear speed, the true nature of the motion is circular. The angle you form when viewed from the center is referred to as angular displacement. Angular displacement. When you are running in a circle, if you were to draw an imaginary line from the center of the circle to your position, that line would rotate through an angle as you move along. The angle covered in this process is what we call angular displacement. Essentially, instead of focusing on the physical distance covered, we are focusing on how much the angle relative to the center has changed. So what do we call the rate at which this angle changes? That is known as angular velocity. Angular velocity. Angular velocity is precisely what describes how rapidly this angular displacement is changing. It is represented by the Greek letter omega. Its purpose is to indicate the magnitude of the angle covered by an object relative to the center within a single second. Here, I have a small question. We established that linear speed is derived from the distance covered while moving along the circumference of a circle. Conversely, we defined angular velocity as being derived from the change in angle observed from the center. In the realm of physics, why are these two considered distinct measurements? Is there any direct connection between them? There is, in fact, a very strong connection. It is expressed by the equation V equals r omega, meaning that an object's linear speed is equal to the product of the circle's radius and its angular velocity. V equals r omega. In the case of uniform circular motion, average linear speed is equal to linear speed. You would be truly astonished to see how this formula plays out in real life. Let's take our own Earth as an example. It takes the Earth 24 hours to complete one full rotation around its own axis, doesn't it? This implies that every single person on Earth, regardless of their specific location, completes one full circle within those 24 hours. In other words, they cover an angle of 360 degrees. Therefore, the angular velocity of everyone on Earth is precisely the same. However, when it comes to linear speed, the entire story changes. If you are located near the equator, your radial distance from the Earth's center is significantly greater. Consequently, your linear speed at that location is approximately 1,600 kilometers per hour. Conversely, if you were to travel to the North Pole or the South Pole, your radial distance from the center would effectively drop to zero. Therefore, your linear speed at those locations would be extremely low. This is truly a fascinating fact. It implies that while our angular velocity remains constant for everyone, our linear speed varies depending on the specific radial distance at which we are situated.